Hello everyone, my name is Mehdi Ousmane and I'm a PhD student at Université Catholique de Louvain in Belgium. Today I have the pleasure to present our recent work entitled A Systematic Procedure for Comparing Template-Based Gesture Recognizer. The context of this work is about to find the best way to compare 3D gesture recognizers. As you know, we interact with many user interfaces in our daily lives. In particular, since sensors have been incorporated into everyday and wearable objects, they have become small, cheap, and ubiquitous. In addition, the design of gesture-based user interfaces is increasingly done with the use of rapid prototyping in order to move quickly to the most suitable design. In the literature, there are many gesture recognition techniques, and in our work, we will focus only on template matching algorithms for their properties. The algorithm matches a candidate gesture with a gesture class represented by many templates in a training set. Now, I will tell you about the evaluation we conducted to answer these questions. To experiment our procedure, we selected 4 3D template-based recognizers from the literature because they are well-known and had promising results. We added to them 2 new gesture recognizers, which are the $PQ plus X, a variant of $PQ plus, and Penny Pincher 3D, which is the 3D extension of a well-known 2D recognizer. To experiment these recognizers, we used 2 leap motion controller-based datasets. The first one is the HCII2022, a dataset proposed in a contest with 5 gesture classes. Whereas the second dataset is Jackknife LM. It was used to test a rejection approach for the Jackknife recognizer, and it is composed of 9 gesture classes. The leap motion controller represents the detected hand with a skeletal model composed of several joints. And for this reason, we wanted to limit the number of joints. That's why we defined it as an independent variable with limited number of joints. So we have 8 values which represent 8 different combinations of joints. You have the first one is the palm. The second one is the palm with the index fingertip. This one is the thumb and index fingertips. This one is the index and middle fingertips. Here we have the palm plus the index and middle fingertips. Here the thumb plus index and middle fingertips. This one is all the fingertips. And the last one is the palm plus all fingertips. As you can see from the image on the right, the gestures are set of trajectories in a 3D space, where each joint is represented by sequential series of single points. After choosing the recognizers, we test them on a series of conditions defined by 3 variables: the number of templates, and the number of points, which is the sampling, and the last one is the number of joints. So the total number of recognitions trial is 240,000 trials performed in a user-independent scenario. We collected the test results through 2 quantitative measures, which are the recognition rate and execution time. In the next slides, I will show you some graphics which represent the results from the evaluation of the recognizers. In this slide, this bar charts show the average recognition rates for all conditions on the Shrek 2019 dataset. In other words, this bar chart represents the average recognition rates for all the tests. As you can see, $PQ plus has best recognition with 85.90%, followed by $PQ plus X and jackknife. On the right part, we see the average recognition rate per gesture class. We remark that for many recognizers, the circle gesture is the one with the low recognition rate. On this slide, and based on the recognition rates, we try to create a ranking of recognizers depending on the two variables, which are the number of points on the x-axis and the number of joints on the y-axis. So as you can see, we selected only the ones with the recognition rate upper or equal to 80%. We selected for each one the best recognition rate. So as you can see here, we have only two recognizers with a recognition rate upper than 80%. Here we have all the six recognizers, and you can see the rank of each recognizer change from a value of this number of points variable to another. So in this slide, we present the recognition rate results as a table or a heat map with a color scheme where the green cells represent the recognition rate upper or equal to 90%. The green one are upper or equal to 90%, and the yellow one are upper to 80% and lower to 90%, and the orange one are the ones which are under 80%. So each combination of conditions is assigned a score or a rank to select the best condition using the Borda method. And for the best condition here has the highest overall score and has the high recognition rate for many recognizers. Here we have the results, the average results for the recognition rates for the recognizers and the execution time for different recognizers for the best condition. Here we have another bar graph which shows the number of recognized gesture for the best condition by gesture class. As you can see, some recognizers have some issue with the circle gesture. So here we have the results of the jackknife LM datasets. On this graph, we have the execution time of the HCII 2019 and on jackknife datasets. So from the results we saw, we can say that the $PQ plus is the best recognizers, even if $PQ plus X and jackknife perform well. Moreover, the family recognizers perform well for the same classes of gestures. And lastly, all recognizers have low response time, which is suitable for template matching. For the jackknife LM datasets, based on the results of the evaluation, we can say that jackknife recognizer is the most adequate recognizer. Moreover, the penny pincher 3D and 3SAN should be avoided. Given the execution time results, we can say that all recognizers are efficient. To sum up, we compared 6 3D template-based gesture recognizers, mainly from literature. We were able to evaluate them on 2 different leaf motion controller-based datasets. In addition, we can have with this procedure a global view of the recognizers and their accuracy, but also a more detailed analysis. The test results showed that the $P plus Q provides excellent results. For the future, we will add many improvements to enhance this procedure, like to add new template-based gesture recognizers and other algorithms which are based on different techniques. We also would propose the effect evaluation of some factors on the measures, like gesture size or the type of gestures. Moreover, we would add other type of gesture data sets to test the recognizers on more complex gestures. Thank you for listening. I'm waiting for your questions.